Thank you all. Thank you for coming in. Thank you for standing. Thank you for packing this place. Actually, it's super, super humbling for you all to come out here for me, little old me. Those of you who are in my first talk, the last 3/4 of this is going to be new content. So stick with me for the first 25%, and then we're going to get to the cool stuff. But the first 25% is important enough that I feel like it bears repeating, even if you've already heard it before. So who am I? Goodness gracious. My name is Dan Griggs. I have my own company, CMD Security. I work for a few government agencies that I can't name right now. I co-wrote the STIG, that's the security guidance for the Department of Defense for iOS 7, macOS 10.9, and 10.10. Just getting spun up on the 10.12 CIS guide. I'm going to help them write that. What we do at CMDSec is we kind of packaged up best-in-class enterprise and sell it as a service. And I say that not to sell my company to you all. I say that I've thought about all of this more than I care to mention, thousands and thousands of hours. And some of these answers are going to seem simple. Some of these answers are going to seem too good to be true. And I tell you, there's a lot of thought behind these. And it all comes together if you just kind of, you have to believe. And sometimes. Thank you. So I choose my words carefully when I say this, and security and management should never destroy the user's experience with the device. I never say not affect, I mean not destroy. The typical secure environment is GPO, everything. Turn off everything. Turn off file shares, turn off admin rights, turn off anything the user can ever do, sometimes even the desktop picture they want to manage. And it's kind of, it's the wrong way to do things in a lot of different ways, and that's what we're going to touch on today, is kind of why it's wrong. We're going to talk about the new kind of paradigm of what if we always were watching? What if we always changed whatever the bad change was back to the baseline with varying amounts of urgency? So if we have that known good baseline and somebody turns on a setting that shouldn't be, we can just change that setting back to what it should be at a later time. So that flexibility lets users, I need to open up a file share for 30 minutes to send a file to a friend. That kind of flexibility to really get work done and really lower the frustration of, honestly, everybody involved, because you'll honestly probably get less help desk tickets. We're going to go through the road to implementing all of this, and then we're going to get into some really cool examples of how you could possibly use this in your environment a little bit later on in the talk. And we're also going to get hyper nerdy a little bit later in the talk, so stick with it. We'll get there. So the government loves their acronyms, and they kind of named this whole approach of always looking, always changing, always monitoring. They call it continuous diagnostics and mitigation. For all of its faults, the government actually is pretty decent at IT security, despite all the other recent breaches. Most of the government is actually quite good at it, specifically the Department of Defense. And what they're doing is they're spending $6 billion to change from the old way of turn everything off, lock everything down, and then never look at it again, to this more dynamic, we're always going to be checking, we're always going to be changing, and we're always going to be monitoring everything about these devices. And it's designed to automatically fix what you can, and if you can't fix it, you somehow put the device into limp mode, whether that is lock out a user, whether it is put a pin lock on the device with an MDM, or it could just be turn off networking. Somehow stop the bleed. It comes to next priority. But it's not without its problems, because overall, security is complex. Users are focused not on security, they're focused on getting their job done, and then threats and vulnerabilities are changing every day. And compromise of a device is nearly inevitable. If you give a device on a network for enough time, somebody will get in if you're not watching. It's just inevitable. There will be some software that's out of date, there will be some mistake that's made. It's unrealistic to believe that nobody will ever get in. So some of the goals we have to kind of adjust knowing that. So we want to know more when something bad happens rather than try and prevent every bad thing from happening. We want to facilitate user workflows that are easier to do. We want to make doing what's right easy and doing what's wrong frustrating. A good example of this is Chrome. Whenever you try to visit a website with a broken cert, it makes you click a few very small links to actually still go through with it. And that small little change makes it super frustrating to go to any site with a broken certificate. You can still do it, so you can still get your job done. It's just, you know now, I probably shouldn't be doing this. And for users, that kind of gets down to that same thing of user training. If you make the wrong thing frustrating, they'll start learning that the wrong thing is in fact the wrong thing, rather than thinking, oh, well, they're just being the typical IT lockdown everything. They don't want me to have fun, basically. And the important thing, lastly, is to think about the device of both the data of both the user and the company on these devices. We want to protect the entire device. We want to give our users a secure platform to check their bank, to do whatever they need to do online, check their mortgage, pay whatever bills, knowing that this device is safe, it is not compromised, it is known good. And I really want to get you all to the point where you're getting thank you notes from your users of, thank you, I now know I can check my bank on this computer and it will always be right. Where my home PC, I have no idea. I run antivirus, but I don't know. It could be good, it could be bad. So with these goals, with these threats, we kind of want to look at, if I was an attacker, how would I get in? What would I do? And here's kind of the general flow Mandiant put out is actually really, really great. So what you would typically do is you establish some kind of foothold on the device. You get in some way. You are able to log in. Then you try to get admin rights. You try to escalate privileges. You try to figure out where you are in the world, where you are in the computer, and then you try to find something more important in that world, whether that is a better user, a better computer, a better server, better data. Whatever it is you're trying to do, you're just trying to reach around, figure out where you are in the world, because they will have zero idea. Unless they really hate you, then they might know. But most part, they will have zero idea where they are in this world or in your computer. So they're going to look around and try to get to something more important. And then ultimately, well, hopefully not, they will complete their mission, which could be data exfil, it could be making yourself have a bad day, it could be wiping your computer, it could just be intermittently making your computer not work just to frustrate you, or to lose data, or to corrupt Word documents, that kind of thing. But to attack, you need a way in. So for that, we need to go over some vocabulary. So the vulnerabilities are basically a mistake in software. And what they do is they categorize these by these things they call CVEs, effectively serial numbers for these threats. There's a big database of these, National Vulnerability Database at NIST. These are all validated vulnerabilities. They don't just, I found one, my name is Dan, off we go. They actually validate it. Is this real? They look at the code and they say, oh, this is real. We're going to track this until it's fixed. And even after it's fixed, it's still tracked. So the exploit is the sequence of commands you use to take advantage of that vulnerability, basically how you'd get in. And then the malware, the virus, or whatever they're trying to do is basically what you're trying to do using the exploit, using the vulnerability. So it kind of builds on each other. And as it seems simplistic, but it's important to know the kind of foundation for that. But that's all right, because Macs don't get viruses, Macs are immune, right? So in the past 3 months, these vulnerabilities, these CVEs, there have been 283 for the Mac alone, compared to Windows 261 and Linux 183. So the 283 is a little bit inflated because there was just a big rack of Adobe stuff that just came out. The real number, if we don't count all the Adobe stuff, is somewhere closer to 200, but that's still 200 different ways I could take advantage of software to get into your device in some way. Most of those is I can run some kind of code that you don't want run on your device. Most of those. Some of those are not, but most of them are. And that's kind of the scale of the problem we're looking at is that's just 3 months. Dial it out to a year. What is it going to be like in the next 3 months? So if you didn't patch in the last 3 months, there's something like 200 different ways. And so what the bad security looks like is that same kind of paradigm where we lock everything down. We turn everything off. Users will find a worse way to do things, I guarantee you. They will find some way to put whatever important file it is on a USB drive and promptly drop it in the parking lot. They will find some way around whatever you're trying to stop them to do in a worse way that you never thought of and would never think to ever do yourself. There's no record of any inventory of the device. We don't know what software's on there. We don't know what ports are open. We don't know what kind of configuration it's in. We don't know what email accounts you have on there. And users will just find ways around whatever it is you don't want them to do, is really mostly the theme of this talk, honestly. They'll find a way. So what a properly secured device looks like. So what we want to do is we want to make anybody who's trying to get in take as many steps as possible. That way we have as best a chance as we can of finding them and catching them in the act. So if I run one command to get into your machine and do everything I want to do, it's going to be hard to catch. But if I have to run 200, that's going to look weird to even a rookie looking at logs. This is strange. Why did sudo run 80 times with the wrong command? Most of the system is going to be open for the user to do work, so they can deviate from that baseline, but it will always snap back. So we don't stop them from changing it, we just will change it back after a set amount of time. That set amount of time really changes for how important that control is. Is it the firewall? We probably want that always on. Or if it's that file sharing example, we can let you do it for an hour and then we're going to turn it off. It's that kind of thought process, and it's we need to really make sure it's only made possible because we're looking at all the inventory of these devices. So basically, we are always checking what ports are open, we're always checking what file shares you have. It's the Jamf recon for those of you who use that software. And we're always scanning for known vulnerabilities. So a couple of the companies that do this are Tenable and Nessus. If you kind of look at their marketing material, you can kind of grok what they're up to. They basically scan for all of those CVEs on your system. And there's also CCEs, which are configuration mistakes. Same kind of deal, they just give it a serial number for configuration mistakes. They also scan for those. So if you start looking at those, start scanning for those, on that National Vulnerability Database, it'll tell you exactly how to check or exactly what is wrong. They'll be able to, you just make a script with that little one-liner, and now you are checking just as if Tenable would. You can really actually learn a lot from the marketing material of security companies. If they're touting it as a good idea, maybe you want to look at possibly doing that yourself, if not buying that product. So you can mimic Tenable or Nessus or something similar. So the big debate is whether you want to use configuration profiles or whether we want to use scripts if I want to configure some kind of preference file. And the thought process really is, if I want something to never change ever, something like the firewall. I want the firewall always to be on. I want password policies to always be on. The user can never turn them off. That would be something that you'd use a configuration profile for. Whereas something more dynamic, something that can be on for a little bit or off for a little bit, we want to start looking more at using scripts for those. That way you get that same kind of dynamic posture where you will snap back after a set amount of time. As meaningful, basically, this whole goal, just to sum all of this up, is really we want to collect as much signal on these devices as possible. By signal, I typically mean logs, and typically that's also some kind of Jamf recon data where you take an inventory of the device. That way you have as much data as possible to make a decision about what is going on about that device. That way, yeah. So all hope is lost anyway, because why take the hard way around when you can just ask the user for their password? Hey, what's your password? I need to install this software. 8 times out of 10, I'm sure you'll get their password. And it's going to be something terrible like Dragon 1994 puppies, though they did capitalize the D in Dragon. So at least there's that. For the GUI prompts, you don't have to be an admin to show a user a GUI prompt. So I don't have to be an admin on the box. I can just get that initial access, prompt the user, hey, local keychain needs your password. Enter in your admin password. They'll enter it. Now I'm an admin on the box. It's that kind of thing. And I didn't call anybody on in the first session, but if you saw a local keychain prompt pop up, you just enter your password. I could probably. I see some nods. Everybody's denying. You totally would. So, and there was also some confusion in the first one what I meant by collecting logs, because sometimes daemons on local on the box are called servers. I'm talking physical, up in the cloud, metal box, different than this metal box server. It's not a complex diagram by any means, but it is just what I'm talking about, because there is a local server for logs. But what I'm talking about when I say log server is off the box, somewhere that you can get anywhere you are and do some searches, do some data analysis, and do some alerting on. So to kind of put this all together in an actual example, so for the sudo rights, what I want is for my users to be able to install software. I want them to be able to change some settings. I want them to be able to customize the device like they would, but I don't want them to run some low-level system commands. So I don't want them messing around with system control and those kind of low-level stuff in SBin is usually what I don't want them to do. So all I do is I remove them from the sudoers file. There's a file in etc called sudoers where it defines who can run sudo commands. So I just remove those users from that file. They can still install software. They can still customize the devices they want, but they can't run those low-level commands. And it is far more elegant than it would seem on the surface of it, because then you can make a self-service button that says, restore a package didn't work, because some of the package installers, like from Verizon and stuff, love to use sudo for some strange reason. They love it. So those kind of packages won't work. So you just make a button in your self-service or your monkey or whatever you're doing that says, hey, an installer didn't work. It will restore their sudo rights for, let's give it a half hour, and then drop them back out. That way they can install that package, no problem. So we're actually going to do this. Before we do anything, do not actually edit your sudoers file. You will lock yourself out of your device. But Dan, I'll just have a root terminal open. It'll be fine. No. But Dan, I'll just have a copy handy. No. No, no, no. I should make a little program that taunts you every time you go into single user mode. Oh, back again, I see. All right, all right. This is some super low-level stuff, and when you edit it with the command they want you to edit with visudo, you have some syntax checking, you have some general sanity checks that they build into the system. When you do it manually like this, you have no filter, you have no safety checks, you have no training wheels. If you put a space where there shouldn't be a space, single user mode it is. So be super careful. What I always do is I just make a copy and I put it into my user folder, and then in my script that I'm testing and making, I make the sudo file a variable. So I just change that to the real one when I'm done, and poof, now it's production. It's a nice, easy way to develop this, test it, and move forward. All right. So as long as everybody promises not to actually do this yet, here is the default sudoers file. So this is what it looks like. On 58, line 58, there's a user entry that lets root run all of the commands available to them. And on 59 is a group. The group is with a little % sign. Admins can run any sudo command. You can get very fancy. You can get very, very granular by doing groups of commands and that kind of thing. I personally feel it's not worth the hassle of doing that. Either you trust them or you don't. Or you can trust them for a limited time or you don't. Trying to dial out different commands, and then you have new commands that show up in the new OSs, and some commands are renamed in new OSs. It gets to be a very big hassle and more security risk than you think you're actually introducing into the system. So in order to remove the sudo rights, it's just as easy as you just comment it. That's all you do. So instead of deleting, I always comment stuff out. That way I know what was there before I changed anything, and I just added myself. So right now on my box, I didn't actually save this, but if I had, I would be the only one who could run any sudo command on my machine. And that's the way you can do it, is you can do very specific users are able to sudo. So if you want to add just your JSS user, just your help desk users, just your help desk user group, you can make a special group just for your help desk support. That way you can limit who has those kind of rights on the box. So this, if we found a line like this, could not be more bad. This is anybody can run anything with no password. And we simply cannot have that happening. They are not trained in that at all, even without the no password. So the no password, anything after the all, will let them do no password. So even if they had a password, it would not be great. And in the back question?
Can this be a directory services group, or does this have to be a local group? You have to repeat the question.
Yeah, so can this be a directory service group, or does it have to be a local group? You can be a directory services group. As long as Discal sees it, it can work. So let's find that command. So it's as simple as a grep. So we're looking for anything that begins with the % sign. So give me all groups that are in the sudo file that are active. We can do the same thing for users on this next slide. what we're looking for is I made a list of all the users on the machine. I'm going to go through that list of users and look for them in the sudoers file. And if they are active, meaning the line starts with just their username and not a hash, so they're not commented out, that means they're active. And I struggle with this because I had to put as much as I could while still making it readable. There is some extra logic to this. Should they be allowed to sudo or not? I'll get to that in a little bit later slide. But this check output array is actually quite a cool thing. So if we append all of these to an array, it's a little bit cleaner than just appending to the bottom of a string variable, and it gives us some extra fanciness if you are in the JSS. When you report it back up, they are nice single line entries. So you can have multiple line entries that are all nicely formatted in your JSS for if you have multiple lines of results. And that's a really, really nice way to have a lot of data in your JSS rather than the one-line results that we typically do. Or if you have a multi-line result, it's all formatted weird. Sometimes it squishes together, sometimes it doesn't. This is nice, clean line breaks on new line, which would be the different array entries. So that's a nice little bonus. It's pretty cool. I thought, anyway. Everybody seems pretty bored with it. So with this, I'm actually saving you from yourself, because you're going to go home, you're going to look at these slides, you're going to go, cool, I'm just going to run this command. I'm forcing sed to do a backup for you. It's going to be sudoers -backup. And what this will do is the top one, I hope you guys can read that. The top one will comment out any group that's in there that shouldn't be, and then the bottom one would, I used the wrong example, forgive me. I was looking for a user, so you just do the username to comment out. You just swap out the bottom one where it says %admin, you put in the username of whoever you want to comment out in your script. So I had a question the other day, why don't you do this through the PAM modules? If there's a sudoers PAM module, in order to use sudo rights, you have to authenticate through that. It's a kind of a different way to go around the tree. The way I don't do it that way is it is very hard to be granular. It's very big changes when you do this. Either sudoers authentication is kind of off or on, unless you get very fancy with some of these plugins. The sudoers file was made for this. The one in Etsy, the configuration file, was made for exactly this problem. So why don't we use the tools that I think it was actually BSD rather than Apple gave us. But in any case, the tools they gave us to do this rather than trying to create our own solution to the problem. That's one of the ones, in one of the themes I want to talk about is basically look at the tools you already have. You don't have to reinvent the wheel. Usually there's already some way to do this. We were talking about the network time protocol port on the CIS meeting, and we were talking about using the firewall to block it, using different ways to do it, and somebody chimed in that there is an ntp.conf file that you just say, yeah, don't listen on any port other than localhost, and then solved. That's the whole problem solved. Much easier than trying to watch for NTP traffic on any port or just that port. Use the tools that they give you, and sometimes everybody misses them, including me. I didn't know ntp.conf even existed. So that one was on me, and it was a cool solution. So sidetrack, how I've been talking about, I got a list of users on these machines and how I did that. So I see so many people just list users in the user folder. And that is so prone to errors, because what if you have a user folder in the var folder? What if you have a user folder hidden somewhere else we don't even think of? Probably not temp, that's a bad idea to do. But anywhere else, really. And I know I'm grepping to awk, but it was late and I was tired and I couldn't remember how to do inverse awk, so sue me. What we're looking for is we're looking for users who have an active login shell. That's more meaningful than users who have an active home, because you can have a shell login but not have a home folder defined. What this does is basically we look for user shell. We drop everybody who doesn't have a login shell. That would be the user bin false. And we ignore also our JSS admin, whatever that name may be. And we get just that first column, which is just the usernames. So what that does, in the example of sudo, TTY is basically for this terminal. In order to get a terminal, you need to log in. In order to log in, you need a login shell. So because we enforce that in order to be able to sudo with these settings here, that we need a TTY. You need to keep track of what TTYs you have, and in 5 minutes, your sudo right authentication will time out. These are all in most of the security guides, by the way, so don't worry about copying these down. This is one of the key ones everybody does in their CIS, in their STIG, and whatever security guide. So what this does is we now have users who could possibly, we have a list of users from the previous slide who could possibly ever sudo. We make sure that the sudo rights are applying to anybody who has a terminal, has a login. So it kind of layers on itself, and there's multiple layers, so multiple things have to fail before a user who shouldn't sudo is able to sudo. That kind of makes sense? It's all kind of built together. We can nod, I can see. So this is all great, but this is all so far just local to the box. So what if we want to do this? So Jamf, the JSS is my tool of choice. So I'm going to go through it with that, but this will work with Monkey, it'll work with Chef, with whatever you're trying to do. The concepts are kind of the same. So in the JSS, for those of you who don't know, an extension attribute is basically a key piece of inventory you want to collect, and that runs every recon. Recon is kind of the process that collects the inventory about the device. So in your extension attribute, here are the 2 one-liners you want to have. These are actually all on one line. I just ran out of space. The sharing will give you the names of the file shares that are available to the device, not necessarily on, but ones that are configured to, if sharing were to be on, this is what would be shared. And then launch control list will tell you if sharing is on, either SMB or Apple File Services. For the purpose of this slide, I cheated a little bit and just did the 2. You probably also want to check for FTP and NFS. But just for the sake of brevity, I kept it just to those 2. And then whenever you are collecting these extension attributes, it's a good idea to always write whatever you find out to the syslog, because that way it gets piped up to your syslog server in the sky, and you can start to run more analysis. What was it yesterday? What does it look like today? And then why did that change? What happened in between? You can start doing analysis like that. So with this extension attribute, we can then make a smart group that anything but secured. So in my naming architecture, I call secured didn't find anything wrong. So if anything other than didn't find anything wrong, I found file share, whatever. I don't care what it is, I just care that you found one. Whenever we find a not secure, we write a Unix timestamp to a file, a hidden file. So I do it in epoch time, however you say it, which is just straight up seconds since 1st of January 1970. And that way you can do some very simple math on seconds then, seconds now, and then do the difference. And it shows you how long it's active. So what that lets us do is we know how long this file share has been on, because in most of these tools, there isn't a really good way to know that kind of thing. How long since this last inventory item changed? Unlike a programmatic. You can, of course, look, but on a programmatic way, it's a little bit tricky to do in the JSS. So off of this smart group, which will auto-populate whenever somebody has an extension attribute that is not secure, I then have a policy, which is effectively an action, that will only scope to people who have something that isn't secured. So the only time this would run is if I have any kind of file share on. And once I trigger that, it will run every, let's call it 15 minutes, even if the computer isn't online. And I block these other out just for clarity. There's nothing configured in those other ones for those of you who are JSS folks. The script will then turn off file sharing once that timer has reached 3,600 seconds, meaning an hour. And here's a little bit of logic in there. So it's really quick and dirty, so forgive me. The timestamp of the file that we wrote down, so it's just going to be a big long number in seconds. The current time in seconds, big long number of seconds. We do a little bit of math, and we find out if it's less than an hour. If it's less than an hour, we just echo it out so we have kind of a record of what it was, and then we exit the script. We don't change anything. As soon as it hits over an hour, the rest of the script that turns off the file sharing would continue. And I didn't include that just for slide space. Sorry, it's a bigger script, and the logic is a little bit complex. But this is the important piece that will follow through, and then the rest of your script will be stuff that you are used to. So basically, it's time for some loggin. So even if you were sitting in the back with your arms crossed, not learning anything today, yesterday was Paul Bunyan Day. Now you learned something. At least you learned one thing here. Excuse me, what we're going to do is we're going to send individual log entries to different individual log files. We're going to start teeing off things we care about. Do we care about diagnostic messages? Do we care about sudo attempts? Do we care about pick a thing? We're going to go through kind of how to create our own log files and how to start piping certain events automatically into those log files. All we're going to use is the built-in syslog file system. So that also helps you out when you start piping logs up to your log server up in the sky, because then you can start paring down. I don't care that Chrome tried to draw a window 8,000 times and it failed, whatever. I don't care about that. I care about the security events. I care about the other operation of the device. And this will let you kind of tune out the log events you don't care about. For those of you in the first talk, that kind of start noisy, pare down, this is how you'd kind of start doing that on the device, and then you'd also do more fine-grained control up on the actual server. And if we can do all this and we can start routing logs, we can start alerting processes on logs, we can start creating devices that will start defending themselves, which is a little bit of foreshadowing for the demo I have a little bit later. It's going to be cool. So the different log levels. So the default is 5. That's just notice, hey, something happened. Anything the lower number than 5 is something bad happened. Anything above 5 is, I guess maybe you want to know this, maybe, whatever. And that's kind of the fall down is most logs you'll see in syslog in console will be log level 5. Unless your machine's broken, then you'll probably be worse. But in a normal working machine, most of them will be 5. That's kind of the default. If you don't define anything with that logger command, the log level will be 5. So some of the files that are included in this and work with this, asl.conf is kind of the top level. Here's all the different settings that need to apply to all log files. And then down into the ASL folders, so it's etc asl/com.apple.whatever feature. That's when you start to get the service-specific settings. If it's a firewall event, pipe it to this log with this file features and these kind of settings to it. And it's really, it sounds terrible on the face of it, but actually it's quite elegant. And when you finally get into it and start looking at these things, actually it's quite cool. So some basic syntax. This is the default syslog file line in asl.conf. This will define the syslog file, its attributes, who owns it, how long until it's rotated, and when it does rotate, how does it do that? So let's step through it a little bit real quick here. So the little forward caret at the beginning of the line, that means we're making a file. We're not doing a query, we're making a file. And it's as simple as, what do we want that file to be called? That's kind of it to that one. That's great. That one's really easy. The mode is going to be the user permissions, so 640, just owner, group, everyone, same as every other file. The format of the log, so BSD is the default for syslog. Standard is the default for every other log. BSD will look like everything else except in console. Console will give you a little bit extra information when you're reading a BSD format log. And the default, there are other options. There's raw, there's XML, and there's ASL. I'll show you raw a little bit later in this presentation. It basically encapsulates every field in square brackets. So it's nice and easy to parse for your Splunks, for your Logstash, excuse me, for whatever tool you're using. So this one is a double duty. It will both enable rotation, and it'll tell you the naming scheme. So sequential is it'll just append to 1, append to 2, append to 3, all the way on up until you hit the file maximum size. So I skipped over compress because that just means compress it when you do rotate it. The file max is how big can that single file be before I rotate it? And then the all max is how big can all of my files be before I start dropping the oldest? And this file max size is calculated on the compressed size, not the actual fully uncompressed size. So if we kind of look at that, we look at something like this, and forgive me, I had to put it on 2 lines. Typically it's on 1 line, but we can kind of tell what this is starting to do. So we want a file called Batman Journal. We want only Batman and group wheel to access it. We want it in the standard log format. We want to rotate and compress after 2 megabyte, and then we're going to keep up to 41 megabyte of Batman logs. It's a nice, easy structure to get up and running on. Actually, and it will be very powerful a little bit later on. It's pretty cool. So as far as log routing, this is going to be some of the cooler bits. So this is, instead of the forward caret, we're going to do the question mark. So the question mark means this is going to be a query line. It means we're going to tell you what we want run on every log file that flies by. The previous examples, we used the forward caret, and that would define what the file would actually be. You don't have to define, so you can just make a query rule and send it to a file that doesn't yet exist. It will figure it out and use the default settings that we defined in the forward caret. But it's best practice, if you're going to send it to a log file, make another line with that forward caret and define what the attributes are. I want it to be owned by me and group wheel. I want it to have, you know, these permissions and rotate after so long. It's kind of best practice to do that. So in here, these are the queries. They're 2 separate queries here. They're both enclosed in the square brackets. So right now we're looking for the sender, which is the sending application called example. And we want any log that is worse than or equal to error. So any log level, then I think error is 3. So 3, 2, or 1 log levels is what we want to pipe to this application. And the cool part is this notify. So the notify, what we can do is we can notify a listening application. There's a kind of a listener and a sender portion to this notify command, notify util command. And what we can do is after a certain number of times we get notified from syslog, we can run something. And that number of times could be 1. Every time I get a notification that this search popped true, run some script. We can also run it after a certain number of times that the script got called. So there's a little bit of flexibility. I want it to run only after I got 40 true events instead of just 1. So putting this into practice, what I did here is for gatekeeper and xprotect. I expanded out on next slide. Don't worry about squinting and reading this. It's just showing you in the broader context of where it is. So this lines 3 through 6 are what I added. So I added 2 lines defining files. So I want to know all gatekeeper events, and I want to know all gatekeeper deny events. So I made 2 log files separated for that, and I made 2 query lines separated for that. So for the just regular old, I want to know every single gatekeeper evaluation process. So what this is I just called it with an A, so it's up at the top, because it's a little bit hard to scroll through all var log. I'm lazy. So just the standard format, except for the format is raw here. So that would be the every field and key pair is in square brackets in the output. I'll show you that in just a second. And then this query line is the sender for gatekeeper and xprotect or syspolicy D. So I want to know everything syspolicy D wants to log, show it to me. It gets a little bit noisy, but most of it is meaningful. On here, so for your sanity, I broke these out onto new lines for the important parts. This is what it looks like. So it's basically key value all enclosed in the square bracket. And you can see on the 4th line, message sent granted for test download JPG. So that's a file I downloaded from the internet just to show the log files. Typically, we would also have your system UUID, but I removed that just because it was big, ugly, and why put that in a big slide? That'll be all over the internet. That didn't make sense to me. So what about if we only wanted to know the deny events? So this is a little bit fancier. Same thing. We want everything run by syspolicy D, but we also want to know if the message contained denied. So the denied would be that red part I highlighted before, would be the message. The message is just a regular old string. So what you do is you can see the message field. The message is actually the message field, and then the actual message, quote unquote, is assessment denied for process ID of whatever. So I'm searching for that denied string in the message field is how I'm doing that. And what's great about this is it is almost free in computing time as far as we are concerned. If you are a computer science major, you will argue that point to your death. But for us, in our scope, almost free. It is extremely, extremely fast. So what we can do if we start doing some of these things, if we start alerting scripts, if we start really parsing out when bad things start to happen, we can start doing on-device defenses. So this will happen wherever you are. Even if you can't talk to our servers, we can make these local processes that will watch for and change and modify things in response to events. So I set up two examples, one of which is for sudo writes and one of which is for firewall events. So for the sudo writes, basically what I'm looking for is an attacker runs a sudo command. It will write to a special log file that will then be popped up to my log server. The log will, syslog will alert a script I have running that's kept alive by a launch daemon. That script will then fix the problem in a way, and then it'll notify the user. Normally you don't notify the user, but just because this is a presentation, I decided to notify the user just so they're not looking at a blank screen and we all go whoop-de-doo. So here's the video. I hope it has enough resolution. So on the top, I'm going to sudo echo I'm bad man. It's going to get a notification center pop up here. Just for the purpose of the script, I just pointed it at the log line we were talking about. So that's what alerted my script. And I made an important event log in var log. So the important event is just looking for sudo actions running. So I don't normally run sudos in all my scripts, so I want to know about every single time somebody sudos something because they shouldn't be doing that. So some of the settings involved in this, we're looking for auth-priv is where sudo will log through, and we're looking for anything worse than or equal to notice. And in my script, I have this looking for the log line. It will see, is that a sudo attempt? You just kind of look for sudo. For clarity of the presentation, I didn't do that here. But in the script, you basically look and see, I got an alert from this. Is that line a sudo command? If not, drop out. And it's as simple as a launch daemon running a notify util with a wait flag. It's that easy. And you give it this key, com.cndsec.test. So whenever the log sends the notify com.cndsec.test, you'll know it'll notify that script. That script will then continue to run. It's really quite cool. So you can make that launch daemon keep alive, run it load, and everything we're looking for in bad behaviors from scripts, we can do that to actually protect the device. The script will then patch the device, or patch the problem and notify the user. Again, notify just because this is a presentation. Typically this would all be silent and we'd just be looking at a blank screen. When I say fix the problem, what I typically do is I look at the user and the group of whoever ran the sudo and try and figure out, are they in a group they shouldn't be? Is the sudo config file in a way it shouldn't be? And if I can't automatically figure it out, I put the device basically into limp mode, kind of like a car, where I'll get you home, but we're not going fast. So I will kick that user off the machine. I will turn that user's login to user bin false, and then get it back home. So that's assuming the user's not the GUI user. I do a check. If the GUI user was trying to sudo, it's just the user's trying to test the fence. Not the worst thing in the world, but also not the best. If it's somebody who is not the GUI user trying to sudo, that's when I kick them off. I change their login to user bin false, and that way all the other protections that we did before start to kick in. We making sense? Okay, good. I'm getting blank stares. It's a little bit unnerving. I know it's a lot. Sorry, I'm trying to cover as much as I can and be as advanced as I can in this talk. I didn't want to kind of come here and have it all kind of fizzle and go, well, that wasn't that advanced. I'm trying to spice it up for you guys. So for firewall events, this situation, somebody is trying to scan the VM that I made. That somebody's me. I was scanning the VM because I wanted to record this presentation. The VM will basically then turn all networking off besides out to my VPN and my JSS server. So you have no networking, but you can still talk to the VPN server to connect, and you can still talk to the JSS to get my commands. And then network is then enabled again once you're on the VPN. And all these triggers are all through scripts, or not through scripts, but they're all through log events. I'm not checking config files. It's all just waiting for log events, because whenever this stuff changes, this is all done, put into syslog in some way, shape, or form. So without further ado, what we'll do is we'll watch this. So I'm just going to prove there's internet on the box just by going to Twitter. Sorry, Facebook guys. I'm going to run the attack on the box. We're going to see the logs go crazy here. My script is waiting for 40 events, just an arbitrary number, just for the test. Want to say it's 40 events of a connection attempt. We're going to have an alert if my video is running slow. There it is, enabling secure mode. So basically, all internet is off on this device until you're back on the VPN. And I made them a nice Jamf helper window with a nice connect button. We're going to try and go to Twitter, and it's going to fail because Facebook is much better. And we're going to connect. Up in the top right, we can see connecting. And connecting. There we go, connected. Nice GUI prompts for the user. Everybody's happy. We can go back to Twitter and tell everybody how happy we are. But what if I want to be a jerk and I want to drop off VPN because I'm just making IT happy, whatever. I don't actually care. Internet will be off again because we saw that happen in the logs. So all this is all triggered off the logs. We'll see that, we'll connect again, and user will be back able to use the internet again. There it is. Sorry, the VM's a little bit slow. So that's kind of the power of these log events. It's that seamless because it won't do these events without writing to the log. If you watch the logs, now you know these events. So if somebody truly hates you, truly trying to attack you, it's possible they could run a command that might not be in the log. But for usual events like connecting to a VPN, turning the firewall off, or that kind of thing, all of those will be in the syslog in some way, shape, or form. So if we start keying off that and we start searching for that, we can start doing some really advanced actions on these devices. So settings involved in that demo is a lot. So what I was looking for is the message connection attempt, because this is a little bit of a developed example. Sorry, faked it a little bit. So I'm looking for connection attempt in the firewall logs. I'm looking for somebody who's trying to scan me. Well, I have a launch statement with the script that is basically watching for that same key. So if both of the scripts in the example were running on the box, I would need a different key. I would need cmdsec.test1 or something like that, because this would actually notify both scripts. So that could be helpful. You could have two scripts listening for the same key. That key triggers, both scripts run. Could be helpful. It tripped me up for a little bit because I was making this in a hurry. Once that count reaches 40, so we do the notify util with a wait for 40. It's just that easy. It's not anything cryptic. We wait for 40 events, and then it will continue on with the script. So in order to turn off the networking, what I did was I edited PF, the actual hardcore firewall config file. I said block all, but let out to my JSS and let out to my VPN. There's some extra little fiddly bit settings, like you need to allow established and that kind of stuff, but it wouldn't fit on the slide. There's lots and lots and lots of documentation on PF and doing this exact kind of thing. So you will have zero problem if you do a little bit of Googling doing the same thing. And then lastly, all I did was just bounce the PF, the firewall. So that's just turn it off and then reload it with manually saying the same config file that it would usually pick, but just for sanity's sake, the actual config file I wanted to define. And with that, I mean, what you should be looking at is not trying to recreate these examples. These are just kind of tech demos for what's possible. If you start looking at logs, you should start looking at kind of the base operations of the system, start looking at how they interact. How can I make sure this is enforced in multiple different ways? How can I check this in multiple different ways? Like for SSH, you can check the SSH config file. There's a flag on the SSH command where it'll show you the values for SSH daemon as it knows them. And you can also just look for if SSH is running or not. There's a couple of different ways to check that. So that's what you need to look at for all of these different services and really make a layered defense and make attackers make as many moves as possible. And if you just, I said this before, but if you just work at it a little bit every day, I promise you, you'll be amazed where you'll be in a few months It just takes kind of deliberate practice. And with that, thank you. I'll just go open it up to questions. Anybody?
There you go.
Oop, in the back, because he's right there next to the box.
I saw that you had your log set to, I guess, log sequentially. Does it make sense to change logging, or what's the case for having it set to log using dates instead of sequential, and then have a rollover instead of by size after like 90 days and stuff? I've seen that being requested by some security teams for logging, but you know, if there's a runaway log of some sort, I could see that log getting pretty large.
Yeah.
Does that matter for, you know, forensics or investigations, like post some sort of breach or event for looking at things, or what's your take on it?
So that's the benefit of splitting everything out into individual logs. We can look at that for individual services. For the firewall, we don't care so much about the big long history. We care more about size, because it could get really big if we try to keep it for 180 days. So for the firewall log file, we could say keep it a maximum of, I don't know, 100 meg, something like that. Or for the syslog, we could start doing time. We could do keep it until there's 180 days, or something like that. You can start parsing out and keeping only what you care about for that big long period. And that's what I kind of did. Sequential was just easy for me for the demo here. I usually do some kind of time-based rotation and using date for the log files.
If the logs are going out to some other logs, it doesn't really matter how long you keep them on. Right? Because you can just, if you need to keep them for a security audit later, you can keep forever on your logs.
That's true. He said if we keep them on a log server separate off the device, why do we need to keep them on the device for as long? And the answer, for me at least, is paranoia. You know, I'd rather have a second copy, because I'll have a second copy there, and I'll have a third copy when they make whatever backup they make of the device, typically Time Machine or Crash Plan or whatever they're doing. So at least there's now in 3 places that I can make sure I have what I need and also cross-check and see if anybody's been tampering. Over there, can we throw in the box? How much time do we have left? I can't see. Oh,
It says 23. Could you talk a little bit about how things like the BSD audit system fits into some of this, and if there's any useful examples? I remember reading through a STIG a while ago, and it was super heavy on audit flags and file auditing.
So BSD audit is a college course in of itself. There's so much to it, I can't do it justice by just a little blurb here. It's more for file system events on a much lower level than the process. So it's much harder to read and much harder to parse and much harder for a human to use, but it is much more useful in a forensic state. So you'd still want it absolutely, but for stuff like this, for triggering scripts and doing these kind of shenanigans, you don't really want the BSD audit logs, but they're still incredibly important in the overall security architecture. Without going too far off the rails, that's probably as best I can do for this one. Sorry.
Is there like a resource that you could point to for an intro to that?
Not off the top of my head. I'm sorry. There's a lot of documentations from the actual OpenBSD folks. They might have some stuff. But yeah, sorry, not off the top of my head.
The link father has blog posts that link to resources.
The link father?
The link father.
The link father. So that's on the mic. Huh?
Rich Trout.
Oh, Rich Trouton as well has some? Okay, so Rich Trouton as well, the Der Flounder blog. Oh, same guy. Well, it's not, I also said, what I said is true, it's just not accurate. It is the same guy. Go ahead up here in the front. We'll toss him the mic.
Very interesting, great job, thank you.
Thank you.
And I wonder, what's your opinion on writing some of these queries and these logs by hand versus using something like OS Query that might have a lot of these kind of built in some fashion?
So OS Query, in my mind, is more querying settings and creating its own logs rather than querying logs that already exist. So it's usually, I want to know all of the launch daemons on a device. I want to know all the launch daemons that run it, load, and keep alive on the device. So it's generating its own new logs rather than reading logs that already exist. So but I see them very much in conjunction. So I use OS Query in some of my alert stuff, but that gets a little bit more complex and I can't fit it on a slide. Mm-hmm. But It is a separate tool that is extremely useful in of its own right, I would say. Anybody else? Oh, up here front. Watch out, drinks though.
Do you do any auditing of your pfconf file? If I've written in some quick rules that would come before your block all, that those would still happen.
Yeah, so the way I actually do it in production is I write down, I use base 64 and echo that out down. That way I can write a file without having to write a package. So I base 64 out to that pfconf, so I know it's a known copy that I have. So I make a copy of what was there, write down mine, and then apply it. And then once the thread is gone, so to speak, I remove mine and put back whatever it is you had. So that's how I get around that. That was the cleanest way, rather than trying to put stuff at the top, or you get conflicting rules. Is like in that kind of situation, I just want a known good configuration file for PF in place. And if you got fancy with it, sorry, it's not going to work for a few hours, and then it'll be fancy again. Anybody else? That might be lunch then. Last call for questions. Cool. Thanks, everybody.